Hello students, welcome back to Science Online class. Today we're gonna talk about static electricity part 2. You can find this in your physics book, page 309. Charging conductors by induction. Textbook page 309 until 311. Conductors cannot be charged by friction, as current can flow through the conductors freely. When negatively charged rod is put near a metal can, this one happens. Take a look at this example. When you put negatively charged rod near a metal can, this can happen. Negatively charged rod has more electrons than the proton, while the metal can has equal number of proton and electron because at first the metal can is neutral. Because of the negatively charged rod, the electrons in the metal can are repelled or are pushed away from the negatively charged rod. In result, the top of the can becomes positively charged, and the bottom of the can becomes negatively charged. We know that unlike charges attract, like charges repel. The rod is negatively charged, while the top of the can is positively charged. That's why they attract each other, while the electrons that are repelled by the negatively charged rod stay in here, at the bottom of the can, because of the repulsion force. Charging two metal spheres by induction. To get to know this, please watch this video.
Let us try to make a metal sphere positively charged by bringing a negatively charged glass rod near it. The metal sphere, which is supported on an insulating stand, is initially neutral. Bring a negatively charged rod near it without touching the sphere. The free electrons in the metal sphere are repelled by the excess of electrons on the rod and they shift away from the rod. The charges cannot escape from the sphere because the supporting stand and the surrounding air are insulators. Thus we see that there is excess of negative charge on the side away from the rod and deficit of electrons on the side nearer to the rod. These charges are called induced charges. Let us see what happens to the charge if the metal sphere is connected to the ground by a conducting wire. The negative charges, that is, the electrons, flow to the ground, whereas the positive charges at the near end remain due to the influence of the charged rod. Now disconnect the sphere from the ground. The positive charge continues to remain on the sphere. Let us see what happens when the rod is removed. The charge is spread uniformly over the sphere. Thus we get a positively charged metal sphere.
If you want to charge two metal spheres by induction, look at these 4 steps. Step 1. Place two conductors on an insulating stand side by side such that they are touching each other. Step 2. Bring a negatively charged rod near sphere A. This causes the electrons in both metal spheres to be repelled to the far end of the sphere B. Now, sphere A has excess positive charges, while sphere B has excess negative charges. Step 3. While holding the charged rod in place, pull sphere B away from sphere A. Step 4. Remove the charged rod, and now spheres A and sphere B have an equal number of opposite charges. Spheres A and B have been charged by induction. Now A is positively charged, while B is negatively charged. Charging a single metal conductor by induction. Step 1. Bring a positively charged glass rod near a metal conductor on an insulating stand. Look at this. Now, negative charge is attracted to the positive charge of the rod. Step 2. Without removing the glass rod, earth the positive charge end of the metal conductor by touching it with your hand. This neutralizes the positive charges on that end of the conductor. Step 3. With the glass rod still in place, remove your hand from the conductor. This stops the earthing process. Step 4. Remove the glass rod, and now the negative charges redistribute themselves throughout the conductor. The conductor is now negatively charged. Discharging a charged insulator and conductor. To discharge charged insulator, there are two ways. Number 1, heat. Ionize the air near the charged insulator so that the charged ions can neutralize the charges. You can find this in your textbook, page 311 in figure 16.8. Number 2, humidity. The water molecules in the air causes the excess charges to leak away, but this is a slower process. Discharging a charged conductor. You can discharge a conductor by earthing or grounding. In this way, you can use your own hand. How does grounding occur? When we touch a metal ball of positive charge, electrons flow from the earth to the metal ball to neutralize the metal ball. Metal ball becomes neutral. How if the metal ball is negatively charged? The extra electrons flow from the metal ball to the earth and the ball becomes neutral. Let's discuss electric field. You can find this in your textbook, page 312. Electric field is a region in which an electric charge experiences an electric force. Electric force is the attractive or repulsive force that electric charges exert on one another. Look at this. Electric field is the area around the positive charge. The other positive charge also has electric field. And both electric charges experience electric force. Field can be illustrated with lines and arrowheads. At the example, in single charge, a positive charge, the lines are directed away from the positive charge, while in negative charge, the lines are directed towards a negative charge. Watch this video to get to know this. Now, what about the electric field lines of two charges? If positive and negative charges, the lines will be like this. The arrowheads on an electric field lines indicate the direction of the force that would act on a small positive charge close by. Look at this. For negative 1, the lines are directed towards the negative charge, while for the positive 1, the lines are directed away from the positive charge. The combination becomes like this. Take a look at another charges, two negative charges and two positive charges. The dangers of electrostatic electricity. You can find this in your textbook, page 314. Click link below. That's all for static electricity part 2. I'll see you on the next meeting, everyone. Bye-bye.